All right, I want to welcome all of you to the PolarConnect event. We're very excited to have Tom Lane and the research team from Healy, Alaska on this snowy winter, April 30th, 2013. At least it's snowy and wintry here in Fairbanks, Alaska, and I'm sure it is in Healy as well. They're going to talk to us about the carbon balance and what is happening with the tundra down there in near Denali. And before we turn it over to Tom and the crew, we're going to run through a few slides here and talk a little bit about the platform and what is PolarTREC and just how this all works. And then we'll have the presentation. And at the end, you'll also have some time to ask questions live to Tom and the team. So the first slide here is a slide with Blackboard Collaborate. That's the platform we're using today. And you should see a list of participants and your name somewhere in there. If you have questions as we go along, you can type them in the chat area. If you have troubles, you can also type those in the chat area, and Sarah and myself will try to address them as we go along. You should be seeing Tom's happy face there from Healy, Alaska up underneath the audio and video window, and he's the only one that will have video today. The rest of you, we turned off your video, so you won't be able to do that. The content should always be changing in the center of your screen, and if you joined us by phone, you need to mute your phone, *6 to press to mute it, and *6 to unmute it. And today's event will be archived. And like I said, if you have any trouble today with the sound or anything, just type in your issue in the chat box, and Sarah and I will try to address it as we go along. Okay, so we'd like to know who is joining us. So if you could type in where you're from and how many students are joining in the chat room, that lets us all know who is joining us today. We won't go around and do a roll call or anything. The other thing that we wanted to let you know about is the PolarTREC program. And PolarTREC, which is what the program that Tom is participating in, stands for Teachers and Researchers Exploring and Collaborating. And it's a National Science Foundation funded program based here out of Arcus in Fairbanks, Alaska. And we match up teachers with researchers such as Elizabeth Webb and Sue Natali, who are on this presentation today. And they go out, and the teachers go out with the researchers and get hands-on experiences and bring that back into the classroom and share what they've learned about the polar regions with all of you. So we're pretty excited about that. Where are we next? So one thing about questions, that during the presentation, we ask that you type your question in the chat box, and we'll try to relay those to Tom and the team as we go along and interrupt if we feel that it's appropriate. At the end of the presentation, you can raise your hand with the little hand button. So that's above the list of participants. There's a little hand icon, and click the hand icon, and that lets us know you have a question, and we'll call on you. And when it comes time to call on you, you need to click on the talk button once to open up your mic, ask your question, nice, loud, clear questions, and then click on the talk button again to close the mic, and then Tom and the research team can address your question. We will go over this again as we get near the end of the presentation. So I think that is all of the our slides, and at this point I'm going to turn it over to Tom.
Hi all, welcome. I'm excited to talk to you about carbon balance and warming and drying tundra. And I have a series of slides here, and we'll go through them, and hopefully you'll have some questions afterwards. I will tell you that prior to coming here to Healy, I didn't have any gray in my beard at all, but now as you can see, it is very gray. Anyway, carbon balance and warming and drying tundra.
Yes, sorry Tom, when you press the talk button, we're getting this a buzz sound, and I don't know where or what that's coming from. So we may need you to call in if you can do so. Try again, or yeah, you can try again too.
Okay. So are you still getting a buzz sound?
Yeah.
The fan, it's probably the fan on my laptop. It just came on. So Elizabeth is turning on her laptop. Maybe we can switch over.
Maybe we can call from my laptop.
Okay.
Do you have Janet, do you have a number? I'll give you a call from my laptop.
Meet Elizabeth Webb, who I'm working with here in Healy.
Hi everyone. I'm excited for our webinar, and I hope that you have lots of questions.
Well, I'll go ahead and get started or continue, and you just tell me if we need to call in. So what we have here is a simple carbon cycle diagram. What's important to focus on here is this plant and soil microbe respiration right here. I can draw a nice circle. That coming out of the ground, that is the carbon dioxide being produced by microbes respiring or taking in sugars and releasing carbon dioxide. You can see there's a couple numbers here, 840 at the top and 1,620 at the bottom in the PG. The PG is a large unit of measure, which stands for petagrams. The easiest way to think about a petagram, I think, is it's first of all 1 billion metric tons, which is not that easy to think about, and then 1 billion metric tons is about 1 metric ton is about 2,200 pounds. So if you take, say, a Honda Fit or something like that, which is about 2,300 pounds, and you take 1 billion of those, you're talking about 1 unit or 1 petagram. So we're talking large amounts here of carbon. As you can see at the bottom there, 2 times as much carbon is located in permafrost soils than what is currently in the atmosphere. Thank you for the finger there. And this carbon goes back into the, as a sink, goes back into the tundra via photosynthesis. We'll get into the importance of this later, but for you guys out there, most of you probably are not environments that have permafrost. This is what is of major importance, because that permafrost will produce carbon into our atmosphere. So how does this ties into how does this research relate to climate change? We know in the northern latitudes we're experiencing a much higher change in temperatures. We have a rise of 2 to 3 degrees Celsius in the last 50 years. And I was speaking with Ted Schur during Shovel Week a couple weeks ago up here at the Cypher site here in Healy. And one of the reasons why he and Sue Natali, hi Sue, got interested in this experiment and put it together about 5 years ago was when looking at talking to scientists, and there was a lot of talk about the impact of permafrost on carbon in the atmosphere, but when they looked into it, there was very little hard data. And so that's the purpose of this experiment. The other important part is the potential for a positive feedback loop or positive feedback loops primarily in permafrost thaw. So permafrost thaws produces more carbon dioxide, which goes into the atmosphere, which warms the atmosphere further, which makes the permafrost thaw more, which produces more carbon dioxide, and those little microbes produce more carbon dioxide, which increases the atmospheric temperature more, so you can see that that's a positive feedback loop. So here's a shot of Sue and Ted, the principal investigators here for the carbon and permafrost experimental heating research off the Stampede Road here in Healy. The picture in the background is actually one I took from the flight from Anchorage to Fairbanks out of the plane window, and the location of the site is way up here in the upper right-hand corners. It's probably just off the screen. At the time when I was flying up to Fairbanks, I knew that this was the area, but I wasn't absolutely positive exactly where the site was. But it's up in this area up here. So the goal of CIPHER, I'll refer to Carbon and Permafrost Heating Experiment Research as CIPHER from now on, is to examine the effects of air, soil, and surface permafrost warming on carbon dynamics in the tundra. So here's some maps of the location. You can see we're in central Alaska, just north of Denali National Park. The Stampede Road's located here, and a close-up of the CIPHER site just off of 8 Mile Lake. We have CIPHER here, and we have what's known as the gradient thaw site also over here on the left-hand side. And here's part of the CIPHER team. We have John Crawford, myself, and researcher I'm working with, Elizabeth Webb here at CIPHER. And the instrument we're using here and some of the tubing and stuff we'll get into a little bit later. So CIPHER has everything to do with permafrost, so it should probably know a little bit about permafrost. It's ground that remains at or below 0 degrees Celsius for 2 or more years. So it can contain all kinds of organic material. You can see, I'm trying to get the finger here. There we go. You can see all kinds of organic material, roots. We have plant, looks like a stem of some type there. It also contains ice, contains all manner of frozen ground. And here it looks like there's some gradient rubble from an ancient stream or river. That's permafrost. And on the far lower right-hand side here, it looks like a mammoth bone of some type embedded in the permafrost. So, of importance to you guys, though it takes up less than 20% of the global surface area, it's approximately 50% of the below-ground carbon pool. So it has an inordinate amount of carbon stored in it. In particular to Alaska, the permafrosted regions is about 80% of the Alaska area. So, major importance around the world, in particular up here in Alaska.
Hey Tom, I'm gonna
it's a diagram of
stop you right there for a quick second. If you could call in, that would be great. The computer buzzing is a little loud, so I don't know if you guys have the phone set there. So thanks for standing by, folks. I know that buzz was kind of in people's ear. I sent off that phone number to y'all, and I can put it up again if you need me to.
All right, we should be here over the phone line now. Do you hear me?
Yeah. Tom, mute your computer. Elizabeth, if your computer's on, mute that one too. And I think we'll be good to go.
I'm sorry, there was so much feedback there. I'm sorry, there was
All right. Mute your computer in Healy there.
All right, is that better?
Much better.
Okay.
I think you're all
sorry about
right
that.
ahead, Tom.
All right. So we have a diagram here of the permafrosted areas in the world, and you can see Alaska here has, you can see almost the entire state is from continuous permafrost to discontinuous permafrosted regions. And that occupies, since there's more land mass above the equator in the northern hemisphere, you can see that permafrost occupies quite a large amount of that land mass. So another thing to know about permafrost is part of it, known as the active zone, thaws every season. And that active zone, or that amount that thaws, varies depending on the temperature. And, well, temperature and other components, but primarily temperature. So that ties into the positive feedback loop. As more of this active zone thaws due to increased temperature, you end up with more melting, obviously more melting of permafrost, but also more access to carbon by microbes, which increases their amount of CO2 emissions, which increases the temperature in the atmosphere, which causes more active zone thawing.
Tom, we have a question. The 7th graders would like to know how warm it gets in the summer to make this active zone.
Active zone thaw? Oh, thank you. I wasn't monitoring the chat box here, but thank you for doing that. That temperature-wise, just from my previous experience from getting my undergraduate degree at the University of Alaska Fairbanks, it wasn't uncommon for it to reach 90 degrees in Fairbanks for a few days during the summer. So 70 to 90 degrees. So its temperature is above freezing.
And it depends. I think last summer our average was maybe closer to 50 or 60, but Tom's absolutely right. The interior Alaska experiences some of the largest temperature swings, and so we do get really hot temperatures like that, 90 or 100.
So at CIPER here, there are 5 ways that carbon flux or change is being measured. And we'll go through each of those quickly. You can see Sodalime, eddy covariance, force diffusion sensors, on-plot chamber measurements, and off-plot chamber measurements. I've addressed some of these specifically in my journals, so those can be referenced for other information. So the Sodalime method is basically the simplest method, and that's just taking Sodalime and putting it in a bucket. Sodalime absorbs carbon dioxide, putting it in a bucket, and then just leaving those buckets open to the soil so that the microbes, when they're releasing carbon dioxide, the carbon dioxide goes up to Sodalime and is absorbed. And then taking that Sodalime, drying it to remove the moisture, and then massing it, weighing it, how much carbon dioxide has been absorbed. The eddy covariance tower, ECT, is located at the gradient thaw site in the, oops, let me go back here. The eddy covariance tower simply measures carbon flux over an area of around the tower itself. And it does this by using a statistical method and in the presence of wind. It needs to have wind in order for that to occur. Since wind doesn't always occur on that site, we'll go back to that slide. There is a second energy tower located there that actually picks up the amount of sunlight, soil moisture, ambient temperature, and is able to gap fill what the eddy covariance tower doesn't monitor. That lower right-hand picture there is a picture of Elizabeth on the left and John on the right there, monitoring the thaw gradient site, permafrost thaw gradient site. A third means of measuring carbon dioxide is the force diffusion sensors. This is a relatively new technology. These have been only in place the past year, and simply it just measures a carbon dioxide movement, and it's determined by a diffusion constant and carbon dioxide concentration in the two chambers you see in the picture there. The off-plot chamber measurements, or snow pit measurements, simply involve the placement of a PVC collar about 6 centimeters wide in the soil, and then, of course, during the winter time, these collars get snowed over, and depending on where they are on the site, the snow depth can vary. And then we take this LICOR, which measures carbon dioxide emissions, with essentially Arduino, which is an instrument actually developed by the Sure Lab that is a timer, and we can put this cap over the top of the PVC collar located at the bottom of the hole and time for a couple minutes and get the carbon dioxide emissions by the soil microbes in the underlying soil. So this involves digging snow pit, placing, we call this cap smiley, over the top of the PVC collar, and then taking a measurement. And that down there in the lower right-hand side is a picture of the PVC collar at the bottom of the snow pit. So those are the off-plot chamber measurements. And here's a diagram or some graph of some of the data collected from that site, I think towards the end of March. And you can see on the vertical axes, we have carbon dioxide concentration over on the horizontal, the x-axis over time. And you can see at that particular plot 1, which happens to be a fairly deep plot, you can see a definite increase in carbon dioxide over time. Some of you listening to the presentation have had Elizabeth and I come to your class with Smiley and actually do these measurements right outside your school on the ground.
Hey, Tom, we have a couple of questions that came up while you're talking. One of the students wants to know from Nell's class why the permafrost stores so much carbon.
Okay, the permafrost stores so much carbon because it has a lot of microbial activity. So you have carbon that is stored there over time due to organic matter being frozen into it. That organic matter, only a small part of it will thaw at any given time, and you end up with more organic matter being deposited in the permafrost over a period of time. So it's not something that occurs quickly within a year. This is generally over thousands of years.
Okay.
Yeah, and I would just add to that. So what we have is we've got photosynthesis going on where plants take up carbon, and they've been taking up carbon over several millennia. And the thing is that it's so cold and also sort of wet up here, so that microbes have a really difficult time breaking down all that carbon that the plants bring in. And so instead of being released back to the atmosphere as carbon dioxide, it's stored in the permafrost because they just can't access all of that carbon. And so that's why over millennia we've just had this buildup of a lot of organic material from mostly from plants. And then this is what we're worried about. Then all of this carbon could be then released back to the atmosphere if it starts warming up, and the microbes then again have access to this carbon.
Okay. And another question from Mr. Locken's class is, if it's spring, why is it snowing even though there is all the extra carbon in the air?
Well, that's a good question, and you guys in Fairbanks are probably particularly concerned about that, as lots of Alaskans are. Considering this morning when I looked out the door here in Healy, it had snowed another inch. But so there is a lot of carbon in the atmosphere in different parts in the world. That carbon oftentimes, by that slight warming of the atmosphere, will take and produce a weather pattern that will actually produce more snow rather than less snow. You guys in Fairbanks know that when it's 40 or 50 below, it doesn't snow. Well, you think it doesn't snow, but it's typically ice fog. So as you warm those temperatures up, it allows the weather patterns to snow actually. The other thing is I think this year is an aberration. So yeah, it's been a long winter, and everybody's hoping for spring here. But I think when we look back, this will just be a spike. Hopefully that answers your question.
Yeah, I think that's great. And Elizabeth, next time you want to jump in, just show us your cute little face out there so we can see you chatting. But thanks, Tom. Go right ahead.
We'll remember. So moving on here, the fourth way that we measure carbon flux at CIPER is the on-plot chamber measurements. And in my journals, I've referred to these, this site or this particular experiment as the fences experiment, because fences are employed, and I think it's really cool. And simply what they do is they're engineered to be of a certain height, and the wind patterns have been monitored over the years to figure out which way the wind normally blows in the wintertime. And by placing those fences, you end up with snow that gets blown up against one side of those fences to a certain depth. And what that snow does is warm the tundra underneath 2 to 3 degrees Celsius. And that's the heart of this experiment, carbon and permafrost experimental heating research. So we're heating the tundra 2 to 3 degrees Celsius, which is what we anticipate in the short term here happening due to climate change, to see what the differences in carbon flux will be. What will happen? Will the tundra overall produce more carbon, or will it start absorbing more carbon from the atmosphere? So on the right-hand side of the fence there, you can see that's the control side where the snow depth is a little lower. In the foreground, this is a little stake which has a whole bunch of tubes to it. And one of the previous slides of the CIPER team that featured John and Elizabeth and myself, that was a close-up. Yeah, thank you. You can see there's a close-up of those tubes go to chambers under the snow at different parts on the site in the warming and control side of the site. And we take the Lycor, which was in that big case, and connect it up to those tubes and can measure the amount of carbon dioxide being produced by the soil microbes in the winter. I think that's on our next slide here. Yeah, there we go. So basically what happens is these are the chambers that are underneath the snow, which I believe Elizabeth, when she tells me they are there, but I have yet to see them. Though I will tell you, unfortunately, while we are clearing there are planks underneath these sites here at this experimental site that you can walk on in the summertime to keep from disturbing the vegetation. While we were clearing them off, we did come across these tubes here over the tops of those planks. But anyway, back to underneath the snow are these chambers, and what we do is we take the carbon dioxide being produced ambient, so this tube here you can see goes nowhere, it's just next to the chamber, and measure the ambient air, and then we connect the Lycor up to these tubes coming out of the chamber, which pumps the air with the carbon dioxide out of the chamber, and we what's called scrub the measurements down to the ambient. What happens is these chambers, if they sit over time, they will accumulate carbon dioxide, produce soil microbes in this, and give you a false high reading. And then after we scrub this down to the ambient air, we can measure the carbon change over time. And for right-hand side here, you can see there's Elizabeth is hooking up the Lycor to these various tubes in the on-plot site. One of the things that has impressed me quite a bit in the last 4 weeks I have been here is Elizabeth and John doing this sampling at temperatures of -30, -35 degrees Fahrenheit. And oftentimes these laptops last only 20 minutes, maybe 20 minutes before the batteries freeze on them and they stop working. And oftentimes they have to do some troubleshooting with these light cores. So I've seen Elizabeth out there at minus 30 degree temperatures without her gloves on, and messing around with this light core trying to fix it, trying to deal with connecting up these laptops right. And that has impressed me quite a bit. She has an extremely high tolerance for cold. I'm standing in the background shaking my hands trying to keep them warm, saying, well, maybe we should do this tomorrow. Nope, we're getting this data. So anyway, it's not an easy job. So here's some data from the on-plot measurements, and you can see over here on the vertical axes we have carbon dioxide concentration again, as opposed to over the horizontal axis over time. You can see that false high reading there, 1,200 parts per million, because of the carbon dioxide that's accumulated in the chamber, and then we scrubbed it down to what the ambient air is actually outside, and then we start reading, and this you can actually see an increase here over time of carbon dioxide. The lower left-hand side here is simply a graph showing the soil temperature over with the amount of carbon dioxide produced by the microbes. And what this graph simply shows is that as you increase temperature, soil temperature, you increase microbial respiration. The different colors are, the blue one is the control, and the red one here is the warming side. So again, that clearly shows as you increase soil temperature, you increase microbial respiration. This information oftentimes is used to, again, when we aren't able to measure, take the on-plot measurements, you can actually gap fill using this information here in the lower left-hand graph to make up those places. Not make up, but you don't make up stuff. It's right here, but to fill in those gaps in the data. The lower right-hand side here, replacing a data card on one of the Campbell scientific loggers. And these loggers just monitor soil temperature and moisture content throughout the year. As part of the on-plot warming experiment, you can see that side of the fence where the snow is built up through the winter, that snow has to be removed, because the experiment is what happens when you warm tundra 2 to 3 degrees Celsius. What does the tundra become a carbon sink or source? By leaving this extra snow that is built up on behind the fences, you end up introducing variability in the experiment, where you're not trying to measure how much moisture you can put into the tundra. Then what happens? You simply want to look at the change. So that snow has to be removed in the springtime, and we call that shovel week. And it's done by hand. It usually takes 9 or 10 people about 4 days to remove the snow from the 3 different plots. And you can see in the lower right-hand side, that's what, from the experimental side or the warming side of the fences, that's what it looks like after the snow has been removed. This year, we were testing a tracked four-wheeler on tracks with a snowblower to see if it would be possible to remove that snow in a mechanical means rather than by hand. And Jamie Hollingsworth from the Bonanza Creek Long-Term Ecological Survey here is operating the snowblower, and he's blowing off snow off the experimental plots, and then we'll compare melt-out, which we think is going to happen sometime this spring. We'll compare the melt-out where he took the snow off with the snowblower to the on-plot sites where we removed the snow as usual by hand.
All right, Tom, I'm going to interrupt real quick. This is Sarah. I like that picture with like Elizabeth maybe, or somebody with their hands on their hips. But we have 2 questions. One is from your school, Bellows Falls, from Anna. If the permafrost is losing carbon, how does that affect the ground surface, and or like elevation of the ground?
Oh, that's a really good
question. Which is if the permafrost is losing carbon, that means it's thawed. And when you thaw permafrost, it generally causes ground subsidence, or what's called thermal karst activity. That relates to the gradient thaw observation site here at the University of Florida's research site here in Healy. That site is monitoring permafrost thaw in an area that has minimal permafrost, moderate permafrost, and extensive permafrost over time. So yeah, it generally causes ground subsidence.
Can I step
yeah,
on that?
Of course.
Yeah, so if we're losing carbon, then when we lose carbon, what we think is actually yeah, you're decreasing that top layer, and exactly Tom was saying is ground subsidence. And we have some measurements that we're doing here exactly to measure that. We have a GPS survey that we do every August, or just about every August, that tracks the elevation of our plots, and so the hope is that we'll be able to track the subsidence over time. And even in our warmed plots, we do see just visually, we haven't quantified it yet, and of course science is all about making measurements and quantifying them. But you can see that in our warmed plots there's a slight decrease in elevation due to this thawing.
Ah, interesting. So,
Was there another question?
Yeah, one of the students in Lucy's class is saying, my students want to know if the microbes are significantly adding to carbon output of Tundra.
Yes.
Yes. Yeah, that's what's being measured here at CIPER is soil microbial output, soil microbial respiration. So yes, that's what's producing the carbon coming from the tundra.
And yeah, and I think Tom has a graph on this a little bit later, so we can talk about that when we get to that graph.
All right. This is Sarah one more time. I'll turn it over to you, Tom. You have about 10 minutes, and then we're going to open it up to questions.
Okay, sounds great. So it's just a picture of the shovel crew there. You've got John Kropik, Elizabeth, who I'm working with, Ted Schuer, who's one of the principal investigators, along with Sue Natali here during Shovel Week. Kathleen Johnston who was a field tech here last year. Verity Salmon, who is a graduate student at the University of Florida, who is actually going to be doing some experiments here with nitrogen this summer. We have Kirsten K. Coe, who is the site manager at the CIPER site here, and then myself. So I don't see a slide there, so we'll move on. Okay, so this is a graphic representation of comparison of the 5 different means by which we measure carbon dioxide emissions at CIPER here. And you can see the off-plot, that's the snow pit method, as opposed to the fences method or on-plot method, as compared to the eddy tower method, is the force diffusion sensors, and also the Sodalime. You can see that what I don't have I should put here is a line at about the 50 grams of carbon per. See how straight I can draw a line there. Oh, look at that. It's actually working. That is the amount of carbon that is actually absorbed by photosynthesis. Back to that original carbon cycle graph early in the presentation. That is the amount of carbon that is being absorbed on a yearly basis due to photosynthesis. So everything above that line is what is being produced by soil microbial activity by the tundra on a yearly basis. So you can see that according to the data here at CIPR over the last 5 years or so, is clearly indicating that the tundra is being a source of carbon due to warming rather than a sink for carbon due to warming. It's interesting looking at the statistical error here. You can see that some of these have absolutely no statistical error. That's absolutely amazing. But the reason being is because there's only one eddy tower here, so there's nothing to compare it to. And the other thing is the forced diffusion sensors have only been online here for a year, and there's only 3 of them.
This is from only 2.
From only 2. So,
but this year we have many more.
So don't think because there's no statistical error that there is potentially. But you can see in the other 3 methods here that the statistical error is very close. So what I'd like to leave you with is to remember that in each method that it's being used here at CIPR, the amount of carbon produced back to a source is in excess of the amount of carbon being absorbed. And so that means that the tundra is an overall addition of carbon dioxide into the atmosphere. Thus, the data indicates that it is contributing to a positive feedback loop that is increasing the effects of climate change. So with that, I would like to open it to more questions, if anybody has any more questions.
Okay, great. Thanks, Tom and Elizabeth. So if you do have a question and you want to ask it live, go ahead and press the little hand icon above the list of participants, and that lets us know that you have a question, and we'll call on you. There was a question that came up in the chat while you were talking. Now, did you go ahead and grab one? Oh, please do. Nell Kemp student wanted to know if all the excess carbon can impact the groundwater. So while people are getting ready, we'll have you answer that one.
That's a really good question.
Yeah, so that's pretty cool. Here at CIPR, we're not studying the groundwater, but there are other groups who are, and what they do is they collect water samples. Mostly it's from surface water, so from creeks or from a lake or something like that. And so they collect the water, and then you can run analysis on it. You can figure out the age of the carbon that's coming out. You can figure out how much carbon is coming out, the quality, like is it a good carbon to eat or bad carbon to eat for microbes. And yeah, so there are whole research projects actually dedicated to figuring out the carbon, carbon sources from terrestrial, so from land ecosystems that are going into water. And so people study that by measuring dissolved oxygen and dissolved carbon in river systems. And around here we're not studying the big rivers, but we're studying little creeks and the lake around here.
Thanks. People look like they're typing into the chat box. If anybody wants to ask a question live, you're welcome to. But we'll just wait a second here while people seem to be typing in.
Yeah, and there's a couple of you that have to, your students have to leave. So if you didn't get your questions answered, just go to the website and post them in the Ask the Team forum, and Tom, Elizabeth, and other members of the team can answer them.
And also, I know, Tom, you added a couple extra slides there. If you want to show people those other slides, we can do that too.
Sure, I'd be happy to. Let me go to the end here and find it.
Okay. Well, you're going to the end, though. We're going to turn it over to Julia West has a question, so we're going to let her go live and ask that question. So, Julia, just press on the talk button once to open the mic, ask your question, and then talk on it again to close it.
Yeah, I watched John Wood's webinar last year, and I've been kind of keeping up. And it seems like last year there was no real conclusion about the fact that there is a carbon, the warming plots were a carbon source. It was inconclusive at that point, and now it sounds like maybe through last summer's data included, or no, you're just talking about winter here, but no, you did say year-round. It sounds like you've decided that, yes, the warming plots are now a carbon source as opposed to just neutral. Is this correct?
Yeah, and I think the difference between last year is last winter we were just taking measurements and I hadn't had a chance to really look at them and write them up in any conclusive fashion, and that's what I spent most of the last fall doing, basically, was looking at last year's measurements, and I haven't had a chance to look at this year's measurements. I think the other important thing to remember is that there is a pretty large amount of interannual variability. So what we're saying based on the data from the winter of 2011-2012 is that the tundra was a carbon source during that year. It looks like it's going to be a carbon source during this year as well. For one, we just looked at growing season 2012, and the numbers for carbon uptake are pretty low. And then additionally, we're having this extra month of winter up here. We've got a meter at least of snow on the ground, and it's the end of April. So it looks like this winter is also going to be a carbon source. And yeah, I guess the conclusions are more conclusive than last year, but we should also remember that it's ongoing and that there will be variability from year to year.
Thanks. Looks like a few people are typing. So Tom, if you want to show those 2 other slides, you're welcome to.
So someone is asking, how deep is the sampling tube penetrating? So we have collars that are in the ground that are measuring the chambers, and both chambers are only going about 10 centimeters into the ground. So it's really just to get a good feel over the soil surface. Yeah. And it looks like Tom's just showing some pictures of around the cabin.
I will real quick. So here's the cabin which we're staying. Here's the front door. This is right behind me. There's a lot of equipment that is still buried under the snow on the deck here. But this was on one day last week when I think it reached 45 degrees actually, and was able to shovel the deck off a little bit. Mike and Corrine, who own the cabin, mush dogs in the wintertime, and one of their dogs had puppies this spring, so it's been really fun to see these puppies grow up over the last few weeks. That's Catherine with some of those puppies there. There's a picture of Corrine in the dog yard here. You can see the dogs in the background there, Corrine and her daughter Sarah. There's John slaving away. John's duties as field tech extend into the cabin and cooking meals sometimes, so he's slaving away in front of the propane stove there in the cabin. Yeah, there's Elizabeth enjoying the, must be probably late afternoon, working on the computer. And here's another picture of Mike in the dog yard hooking up some teams. They use the dogs to go get firewood in the wintertime. Virtually any day that is good for mushing, they'll hook up a team of 8 to 10 dogs, and 2 teams sometimes of 8 to 10 dogs, and run down to the Savage River and get firewood for the remaining part of the winter. Here's another picture of the puppies taking advantage of John there, looks like. And obviously John really likes those puppies. So anyway, it's been really interesting. It's been really fun.
All right. Yeah, I'm surprised that you guys haven't all decided to take a puppy home, or maybe John did do it. All right. Well, I think a lot of the people are starting to go. I see somebody was typing something, but I don't know if they've gotten their question out there or not. But I think we're close to wrapping up. And just a reminder to everybody that joined today, we will post this event on the website, as well as send it out to everybody that registered. And again, if you didn't get your questions answered, or please post them on that Ask the Team forum. This is a busy time of year for PolarTREC and for Arctic science in particular, although we do have an Antarctica project also coming up in late May and early June. But be sure to follow along on PolarTREC. There's lots of expeditions and some more live events coming your way in the next few weeks. So be sure to follow us and see what's happening. And just a big thank you to Tom and Elizabeth for putting on this great presentation today and for all of you to join us. Oh, and we forgot one thing.
Oh, yes, we did. It's Sarah's birthday today.
It is Sarah's birthday today, so we will sing her a happy birthday in whatever language you know how to sing happy birthday to.
All right.
Ready?
So,
3, 2, 1.
Happy birthday to you. Happy birthday to you.
Happy birthday.
Happy birthday to you.
Too cute. That's my first internet birthday.
Even with the delay and everything.
Thanks, guys.
All right.
Thank you, Sarah.
Have a good one, everybody.